So I'm going to show you how to solve the aluminum foil lab. You had a little cylinder and you were to mass it. And let's say the mass of that little aluminum cylinder worked out to be 10.80 grams. 4 significant figures from the scales. Then you were supposed to get the volume. Let's say after you figured out the volume through displacement, it worked out to be 4.0 milliliters. 2 sig figs. Now remember that a milliliter is the same as a cubic centimeter. In the metric system, that is a big deal, that you have a standard length that associates to a volume. So centimeters are going to be a lot more handy when we're doing these calculations. Now the other thing you were trying to figure, well, the other piece that you had was the aluminum foil. Okay, so this one was the cylinder, and now I'm working off the foil. Well, the pieces of information that you knew about the foil, you calculated the mass. So the mass of the foil was something on the order of 0.43 grams, 0.43 grams, 2 sig figs, all right? And you also had the length, and let's say you used the ruler, and if you used the ruler right, you would have gotten something like 9.26 centimeters, and the width of, say, 10.31 centimeters. Okay, so we knew the length, we knew the whatever. What we were missing was the little teeny thickness between there. So these are the values that should have been included in your data table, okay, because those are the hard numbers that you physically use to measure with tools to get an amount. Looking at the significant figures, the ones that give you the fewest are either the volume with 2 or the mass of the foil right there with 2. So 2 sig figs is what my answer is going to have. Now what do I do with these numbers? Well, the first thing I want to do is I want to calculate the density. So I want to find the density of aluminum. Okay, because mess that up just a sec. So anyway, I'm looking for the density. I'll write it better. Density of aluminum, AL. It's going to be the same, but what I'm going to use for the density are these two values right here, because density is mass over volume. So if I take 10.8, so the density will be equal to 10.80 grams divided by 4.0 cubic centimeters. Now, just like on your lab, I want to see all of your calculations, and I want to see all the units and everything else. So when I do this, I end up with 2.7 grams per cubic centimeter. I have 2 sig figs there. My answer better have 2 sig figs, and it does. Now, that 2.7 grams per cubic centimeter is for every bit of aluminum that there is. All aluminum has the same density. So the next step is I want to find the volume of the foil. Well, the way I'm going to go about doing that, again, I'm using density is equal to mass over volume, but this time I'm starting off with the density, grams per cubic centimeter. That's going to be equal to the mass of the aluminum. The mass of the aluminum happened to be 0.43 grams. So I have a 0.43 grams right there divided by the volume. Solving for the volume then becomes, I'm not sure, I've got to do it. So to solve that, I'm going to divide 0.43 by 2.7. The volume works out to be 0.1592. Well, that's enough. I have 2 sig figs there. I have 2 sig figs there. I got to round this to 2 sig figs. So to do that, I'm going to bring this back and call it 0.16. In red now, but we'll just do that. 0.16 centimeters cubed. Okay, so that's the volume of the foil. Now, on the foil, I know the length and the width. So length times width is going to be the area. So those two values right here, when I multiply those together, I end up with 9.26 times 10.31. I end up with an area of 95.2 centimeters squared to 3 sig figs. All right? If I know the volume here, and I also know the area, oops, I did something really bad right there. It's not cubic centimeters, it's square centimeters. Okay? So I have the area right there. If I divide the volume by the area, I am going to get the thickness, T. So I'm going to take 0.16 cubic centimeter divided by 95.2 centimeters squared. And when I do that, I get T being equal to 0.001, and I have to round it to 2 sig figs, so 0.0017. All right? Put a unit on there, centimeters. It looks like that. That zero's looking kind of cruddy, so I better do it again. All right? So that's what I calculated the thickness to be by using the density of aluminum. Now the last little part I wanted you to do was a percent air calculation. Percent air works like this. It is equal to the true value minus the observed value divided by the true value times 100. On the board, I said that the true value was 0.0016 centimeters. The observed value that you calculated, or you did, was 0.0017 centimeters. That whole amount is divided by the true 0.0016 centimeters. And I got to multiply it times 100. Okay? You can hardly see it, but that is times 100 right there. Good enough. What am I going to get out of this? So I get an error of 0.0016. The percent air turns out to be 6.3% air. Okay, so that's how far off I was, which is really pretty good. So try to do that with your own numbers and get it done.